Good morning, everyone. Today, I would like to share with you the key ideas from a book titled Finding the Next Giant Deposit, Modern Exploration Strategy in a World Where the Easy Discoveries Are Gone, by Andi Anriansyah. Let me begin with a simple question. If the Earth's largest mineral deposits are still out there, why are they becoming so difficult to find? For decades, mineral exploration was relatively straightforward. Geologists could often see the clues. But that world is changing. Today, many of the most attractive mineral deposits are no longer sitting close to the surface. They may be hidden beneath thick cover. They may lie hundreds or even thousands of meters underground. And sometimes, the surface gives us almost no obvious indication that a major deposit exists below. So the fundamental challenge facing modern mineral exploration is not simply, where is the next deposit? The real question is, how do we find something that we cannot see? And this is where the central message of the book begins. The end of easy discoveries. The book describes the transition from what we might call the golden age of surface discovery into a much more difficult era of exploration. In the past, many major deposits could be discovered because they had strong surface expressions. Today, explorers increasingly have to deal with three major challenges: depth, cover, and geological complexity. Depth means that the valuable part of a deposit may be far below the surface. Cover means that the geology we need to understand may be hidden beneath sediments, regolith, volcanic rocks, or other materials. And complexity means that geological history may have produced multiple generations of deformation, alteration, and mineralization. So modern exploration cannot simply rely on looking at the surface and following an anomaly. It requires something much more sophisticated. It requires geological inference. Why exploration programs fail. One of the most important sections of the book discusses why exploration programs fail. Interestingly, the book argues that failure is not always simply bad luck. There are 5 major failure modes. First, the geological model can be wrong. Second, different datasets may not be properly integrated. Third, the target may not be adequately tested by drilling. Fourth, a genuinely prospective target may be abandoned too early. And fifth, the exploration portfolio may be poorly constructed. This is extremely important. Because sometimes an exploration program fails not because there is no deposit, but because the company asked the wrong geological question. Or because the right evidence existed, but different teams looked at it separately. The geologist looked at the geology. The geophysicist looked at the geophysics. The geochemist looked at the geochemistry. But nobody connected all the pieces. And sometimes, that is where the discovery opportunity is lost. Understanding the mineral system. The book then introduces one of its most important ideas: mineral systems thinking. Instead of looking for a deposit as an isolated geological object, we should understand the complete system that created it. We need to ask, where did the metals come from? Where did the fluids come from? How did they move through the Earth's crust? Where did they accumulate? And what geological conditions allowed them to become economically concentrated? In simple terms: source, pathway, trap, preservation. If we understand these components, we can begin to predict where mineralization is most likely to occur. This is much more powerful than simply searching for a familiar geological pattern. We are no longer asking, where have we found deposits before? We are asking, what geological system must exist for this deposit to form, and where can we find evidence that this system is present? From province to drill target. The book also presents exploration as a progressive filtering process. We don't begin with a drill hole. We begin much further out. First, we ask whether an entire geological province is prospective. Then we identify prospective districts. Then prospects. Then specific targets. And finally, we decide where to drill. So the exploration process becomes province, district, prospect, target, drill hole. At every stage, uncertainty should decrease. And the quality of evidence should increase. This is important because drilling is expensive. We should not use drilling to answer questions that could have been answered more cheaply through geological analysis, geochemistry, or geophysics. The drills should be used to test a strong geological hypothesis. Technology is powerful, but it is not the answer by itself. Modern exploration has extraordinary technology. We have airborne geophysics, gravity surveys, magnetics, electromagnetic systems, induced polarization, satellite imagery, hyperspectral data, advanced geochemistry, three-dimensional geological modeling, machine learning, artificial intelligence, and increasingly sophisticated drilling technologies. But the book makes an important point. More technology does not automatically mean more discoveries. Technology gives us more information. But information is not the same as understanding. The real competitive advantage comes from knowing. Which information matters? How does it relate to the geological model? And what decision should we make because of it? The power of data integration. Imagine that we have three pieces of evidence. The geochemistry shows an anomaly. The geophysics shows a response. And the structural geology indicates a major fault intersection. Individually, none of these may be convincing. But if all three point toward the same location, the probability that we are looking at something important increases significantly. This is the philosophy of data integration. The goal is not to collect more and more data. The goal is to make different datasets tell one coherent geological story. That is one of the central principles of modern exploration. Artificial intelligence and 3D modeling. The book also looks toward the future. Artificial intelligence and machine learning can process enormous quantities of geological information. They can identify patterns that humans may not easily recognize. But AI is not presented as a replacement for geologists. Instead, it should become a tool that augments geological reasoning. The same principle applies to three-dimensional geological modeling. A 3D model allows us to transform a geological idea into a spatial prediction. Instead of saying, "I believe there is a fault-controlled mineral system somewhere in this area," we can create a model that says, "Based on the available evidence, this is where the structure, alteration, lithology, and geophysical response converge, and this is where the next drill hole should test the hypothesis." And importantly, the book emphasizes uncertainty. A geological model is not the truth. It is a hypothesis. And a good exploration model should tell us not only what we think we know, but also what we don't know. Exploration is a probability game. Another powerful concept in the book is that exploration is fundamentally probabilistic. The book expresses discovery probability as P discovery equals P geological times P detection times P target times P economic. In other words, a discovery depends on several conditions. First, the geology must actually contain the type of deposit we are looking for. Second, our exploration technology must be capable of detecting it. Third, our drill targeting must successfully intersect it. And finally, the discovery must have economic value. This changes how exploration should be managed. We should not ask only, "Do we believe this target will succeed?" We should ask, "Where is the uncertainty, and how can our next dollar of exploration reduce it?" That is a much more disciplined way of thinking. The importance of exploration persistence. The book also tells us something uncomfortable about exploration. Sometimes the biggest mistake is not drilling a bad target. It is giving up on a good target too early. History contains major deposits that were explored before they were properly understood. Kamoa-Kakula is one example. Nova Bollinger is another. Oyu-Tolgoi provides another powerful lesson. At Oyu-Tolgoi, the surface and shallow mineralization did not reveal the full scale of the system. The critical breakthrough came when geological interpretation and geophysical evidence suggested that a much larger, higher-grade system could exist deeper underground. Deep drilling eventually revealed significant mineralization at depths of approximately 800 to 1,200 meters. The lesson is clear. Sometimes the most valuable part of a giant deposit is the part that surface exploration cannot see. The human side of discovery. But perhaps one of the most interesting ideas in the book is that discovery is not only about geology. It is also about people. A company may have excellent geologists, excellent geophysicists, excellent geochemists, excellent data scientists, and excellent drilling engineers. But if these people operate in isolation, the organization may still fail to discover anything. The strongest exploration organizations create an environment where different disciplines challenge each other, share information, test assumptions, and build one integrated geological model. The book also emphasizes institutional memory. Why? Because companies often forget why previous explorers made certain decisions. A database may tell us that a hole was drilled, but it may not tell us why was it drilled? What geological model was being tested? Why was the target abandoned? What alternative explanation existed? And what did the previous team learn? Preserving this knowledge can turn decades of exploration history into a strategic advantage. The future of exploration. So, where does the book believe exploration is heading? Toward deeper exploration. Toward better geophysical systems. Toward advanced drilling. Toward artificial intelligence. Toward large-scale three-dimensional geological models. And eventually, toward what the book calls the virtual lithosphere, a digitally integrated representation of the Earth's crust that combines geological, geophysical, geochemical, drilling, and other information. Imagine being able to explore an entire geological province digitally before deciding where to spend millions of dollars on drilling. That is the direction the industry is moving toward. But again, technology alone is not enough. The quality of the final decision will still depend on the quality of the geological thinking behind it. The central framework. Ultimately, the book brings everything together into what it calls the modern mineral discovery framework. It combines mineral system understanding, geological targeting, data integration, geophysical detection, geochemical vectoring, three-dimensional geological modeling, and portfolio strategy. These are not independent activities. They form one integrated discovery system. Final message. So, what is the biggest lesson from this book? I believe it is this. The next giant deposit will probably not be found simply because someone has better technology. It will be found because someone has a better understanding of the geological system. Someone connects the evidence that others considered separately. Someone is willing to challenge an outdated geological model. Someone understands uncertainty. Someone knows when to drill deeper. Someone knows when to stop. And perhaps most importantly, someone knows when a negative result does not mean that the geological opportunity is gone. The easy discoveries may be gone. But that does not mean the giant deposits are gone. It means the way we discover them must change. We are moving from an era of seeing the deposit to an era of predicting the deposit. From surface observation to subsurface inference. From isolated datasets to integrated intelligence. From individual projects to portfolios. And from exploration based primarily on experience to exploration based on geological models, evidence, probability, technology, and disciplined decision-making. That is the central message of finding the next giant deposit. The next giant deposit may already be there. The real challenge is not whether it exists. The challenge is whether we are capable of seeing it before we drill into it.